Today we're going to be talking about the chain rule, which is when we take derivatives and we have a composition of functions. So let's look at this derivative here. So we have 4x squared minus 3x plus 2. And when you square something, it's like multiplying by that same thing. So let's use our product rule. Derivative of the first, leaving the second alone, plus leaving the first alone, derivative of the second. So when you look at this, we really have two of the same terms. So what you need to think about is look at how this compares with our original function. Notice how the 2, that was our exponent, came down. We have the f of x function, and then we have the derivative of the inside. Okay, so this is setting up our chain rule. So if we wanted to find the following, the derivative of x squared plus 1 to the 100th power. I don't want to write out this to the 100th or have to multiply it out or something like that. But we can write this as a composition of two functions, where f of x is our outside function, and g of x is the inside function. And now we take the derivative of both of those. Now, if we do what we call kind of like a U-Substitution, so we have this function y equals x squared plus 1, and we let u equal x squared plus 1, so y equals u to the 100th power. dy du, the derivative of y with respect to u, is 100 u to the 99th power, and then derivative of u with respect to x is 2x. So then to find dy dx, we take dy du and multiply it by du dx. And let's look at what we have. We have 100 u to the 99th times by dx. But u, we said, was x squared plus 1. So notice again what happened. Exponent came down in front, exponent came down in front, reduce your exponent by 1, and then what I always say is derivative of the inside. So we have our chain rule, okay, where you have a composition of functions, and you have to take the derivative, so f prime of g of x times by the derivative of the inside. And I look at it like layers of an onion, and you keep taking the derivative of each inside function until you get to the very last function. So now a shorter way to do this, bring down the 2. The outside function is this, times by the derivative of the inside function, which is that. So another thing that we have going on here in this example, that's f and that's g. So our f of x function is 3x squared, and here is our g of x function. I have two functions being multiplied together, so we have to do our product rule. So I take the derivative of the first. Okay, now let's take the derivative of g of x. This is a composition of functions. This 2x is technically a function inside of our derivative. So derivative of cosine is the negative sine of 2x, and then you need to multiply that by the derivative of the 2x. So we have derivative of the first, leaving the second alone, plus leaving the first alone, times by the derivative of the second, now simplifying that out a little bit. Now I meant to simplify out and I wanted to write a little negative in there because this term is negative. And again, you could factor out a 6 and an x if you want, but I'm okay if you leave it like that. Okay, now this one is like saying x cubed plus cosecant x to the 1/2 power. I recommend you do that. So what we have is we have the inside function is that, and then we have the whole outside function, which is something to the 1/2 power. So dy dx in this case is equal to derivative of the outside function. Times by the derivative of the inside function. Now something you want to make sure you do is put the derivative all in parentheses. In my opinion, you could leave it like this. Now, if you're looking at multiple choice on an AP exam, they are going to simplify that out for you. So just remember that the 2 would go in the denominator, and they might write it like this. Okay. Next, this has 3 layers to it. So I have the sine of something, and then I have this 1 plus the cosine of x to the 1/2. And again, I look at it like layers of an onion. Sine is the outermost function, so I take the derivative of that first. Derivative of sine is the cosine, leaving everything inside as is. I don't take any derivatives of anything yet. Now, the next innermost function is this 1 plus cosine to the 1/2. So that I bring down the 1/2, derivative, or I leave the 1 plus cosine x alone, make that to the negative 1/2 power, and then lastly, we take the derivative of 1 plus cosine x, which is derivative of 1 is 0, so negative sine of x. And then here, this is a matter, you can leave it like that. I'm okay if you guys leave it like that. Something I might be a little picky on, let's put that in parentheses. But this term, again, would go in a denominator, so that 2 square root of 1 plus cosine x might appear in a denominator, whereas everything else would appear in a numerator. In this example, we have a few more layers to our derivative, and we have another trick. That tangent is really to the 5th power. So when we're taking our derivative, you have the outermost function we have to take the derivative of, leaving everything else exactly as it is. And remember to put it to the fourth power. Now move to the next inside function, which is tangent. So derivative of tangent is the secant squared and then we have the next innermost function, which is times by 18x squared minus 2. Now, a few students always ask me, why don't we take the derivative of secant squared? Well, that wasn't in the original problem. The original problem was tangent, so I took the derivative of tangent and then moved inside to all of our different composition functions. Okay, that is it for today. Please make sure you submit your lesson summary below this video on time.